Okay, so I'm going to look at, so we're going to do one now where we have two unknowns and I'm going to ask you to solve it. All right, are we listening? All right, so we haven't done this before. We're going to do composite functions where we have to solve two different letters. So I'm going to say that f of x is ax squared, okay? And x is all real numbers again. Then g of x is going to tell me that 3x plus b, where x is again all real numbers. So I've now got a's and b's in here, right? We know with simultaneous equations, you can't solve for two unknowns at once. But when we use composite functions, we can do that substitution elimination thing where we do end up solving, well, it's really the substitution method, right? This is a very fancy substitution method. We already know how to do this type of thing. All right, you're also being told that A and B are constants, which we should take for granted, but it's nice that they tell us, right? So they're not some weird tricky thing. They're always going to be the same number. All right, so let's have a look. So what if I just ask, okay, so I'm going to also give you some more information. So I'm going to tell you that G of F, where it's 1, is 5. And I'm also going to tell you that G of G, when it is 2, is 14. So you're given extra information now, okay? So what we can do is find GF of 1, right? So let's do that. All right, so let's do this one here. So we're going to start with G, so 3x, but instead of x, we're going to use this. So we have ax squared plus b, all right? So let's substitute what we do know. Okay, first of all, what does this equal? 5, right? Do I know anything else? X is going to be 1, right? I've been told that instead of x, I should be using 1. So 3a1 squared, that's not really very interesting, is it? So then, that was very stupid of me. Thank you very much. It was 3a plus b equals 5. All right, so that gives us one piece of information. We've done everything we can. So let's go over here and use this one now. All right, so we need G inside itself. So 3 instead of x, I'm going to do 3x plus b. And what does this whole thing equal? 14. Oh, thank you. Yes, I did. Look at me. Plus b equals 14. All right, so now we have 9x plus 3b plus b is 14. So 9x, good, thank you. So 9 times 2 plus 4b is 14. So look at this, we've only got one unknown here, don't we? So what's b?
That's H.
Ooh.
Oh,
why is this so terrible? What's happening? I don't know. What did I just do? No, that's fine. Yeah. 14 minus 18 and b's 4. Yeah. We're all good. -4. Okay. So now that I know. Oh my gosh, what is wrong with me today? Okay, let's have another. Yeah, shut up. That's 4. Yeah, because I wrote such a terrible 4, I can't even read my own writing. So then b is 1. -1. This is the best lesson ever. Do I want this on YouTube? Maybe not. All right. Okay, how did you get that? Okay, so I'm going to go back over here, right? So if b is -1, then 3a minus 1 is 5. So then a is 2. All right. So now we have a is 2 and b is 1. Yay.
yeah.
What do you mean? Oh, I see what you're saying. Yeah, sure. Absolutely. And if you can recognize that before you start your work, great. Yes, you have to be. Yeah. Okay, so what if, no, actually, the rest of it's all the same. Okay, we are going to do exercise 2.2 today, composite functions.